Hello from Turkey and Hacettepe University to everyone. I am the captain of the Space Troopers team, Ufuk. This is the first on-site rover of the Space Troopers team. Space Troopers is a rover team established in 2019. The team participated in 2023 remote category and achieved 10th place. Our team currently consists of 22 members, including engineers and engineering candidates from various departments. Additionally, we work within 5 different sub-teams.
The main reason for our participation in the European Rover Challenge is our desire to learn. As a team brought together by a passion for research and development, we started working to take the project as a step further. As the process progressed, achieving success in the competition became our main goal. With the opportunities provided by our school and sponsors, we are working as a team towards this goal. During these efforts, we are confident that we are learning a lot from each other as a team and that we will leave the project as a guide for future teams.
The electronics team manages embedded system programming, motor drive controls, and the electronic communication process. Additionally, they organize all the power systems on the rover. The power that provides the rover's movement is provided by a 24-volt LiPo battery. We need different voltage levels in the components at the different points on the rover. We also provide this by using different regulators. Driving is achieved using 4 DC motors. The motors get their power from the drivers. The communication between motors and driver is provided by UART protocol. We use serial communication protocol between Jetson O-ring and microprocessor to control different components on the rover from one place. We provide communication between the ground station and the rover using a 2.4 GHz Wi-Fi modem.
We use STM32 to provide movement in the driving system and the robotic arm. We've done lots of research on positioning, which is one of the most important features of the robotic arm. As a result of these researches, we use the encoder data of the motors with motor drivers that we have carefully selected to adjust the position. An easy-to-use card that can receive data from the load cell was used to determine the weight of the sample that is intended to be taken with G. After the card was calibrated, the measured value has 1 gram uncertainty. Using RGB LED, an indicator lamp was made that provides status information including green, yellow and red. The transition between the colors was provided by LED driver. For the droning subtask, we are using a commercial DJI Mini 2 SI. We will be using a powerful third-party API Lithium. We plan our mission precisely to meet the needs of droning subtask. Using the commands the Lithium offers, we plan to execute the task flawlessly.
The chassis of the rover is made of aluminum signal profiles to be solid and easy to connect. Static balance is provided using a rectangular profile. Rocker bogie suspension system is used in the movement of the rover. Thanks to the system, it is ensured that the rover moves on rough surfaces without losing contact with the ground. The wheels are painted with TPU material and rims are produced using PLA. Thanks to the TPU, both flexibility and durability are provided. The movement of these wheels is provided by 499 Nm DC motors. These motors' torque has been calculated and selected so that the rover can comfortably climb slopes of 30 to 45 degrees. The robot arm is designed to be 1 meter long and 6 degrees of freedom. The robot arm is made of carbon fiber pipes and the connection is made with PLA parts. The movement of the link 2 and base link is provided using a play belt system. The movement of the robot arm is provided by DC motors and servo motors. Differential vary system consisting of bevel gears and ball bearings is used at the end of the robot arm. Thanks to the system, the gripper can move both up and down and around its own axis. By this way, it is easier for the robot arm to reach and grab the sample. Archimedes screw is used in the drill system. Thanks to the system, the circular motion is converted into linear motion and thus the soil sample can be easily lifted upwards.
Hi, my name is Ali and I am at the head of software team which consists of 4 talented members. As software team, our purpose in this project is giving life to our rover. To do so, our journey began with the generating simulation environment and simulation of rover, robotic arm and drone. Our autonomous movement is achieved by the help of LiDAR, stereo cameras, IMU, motor encoders and with GNSS technology. With all data gathered, then our path planning, obstacle avoidance and some algorithms will be subject to use. Those algorithms are developed in ROS and gazebo environment. Besides of the simulation, the algorithms that we are developed is going to work in the NVIDIA Jetson O-ring. Jetson is connected to the microcontrollers and it will autonomously run the embedded software in it. Our ground station will control 4 cameras as well as speed control, battery control and currently running ROS-rated software. By doing so, we'll be able to fully control our rover in case of emergency. Ground station will be developed even more in time, parallel with the further developments of task-rated subsystems.
As the science team of Space Troopers, our main goal is to understand the geological evolution in the Valles Marineris region and to apply this knowledge on Mars Yard. Our study for the science task has been continuing for a long time. Our studies continue with both detailed literature review and remote sensing on the Valles Marineris region. We have already determined 4 different landing sites in the relevant region. We think that these also meet the geological interest condition required by ERC. Additionally, we continue to work with other subteams. These studies we plan to add the rock abrasion tools, which was also used in previous Mars mission, to the system until the ERC 2024 final. Finally, we continue to work on systems such as electronic system and the lithological identification with machine learning algorithms.